Simplifying rationals, because this week we're going to look at adding, subtracting, multiplying, and dividing rationals. And again, once you do all those operations, what you want to do with all fractions is to simplify them. So this is probably the most important part because it involves everything from here on out. Being able to simplify a rational. Maybe it's easy. The calculator will help us. A lot of this is also going to be with our laws of exponents, as you'll see. So let's go through some of these and help simplifying a rational, because this is going to be our final step regardless of whatever we do this week. I have 24x squared times x over 32x y cubed, and I want to simplify this fraction. I would say go one step at a time and look at each of these numbers separately and simplify them separately. First thing, I have constants, 24 over 32. How does that simplify as a fraction? 25 over 32 parts. 6? Okay, 6 may work. There's another number that's bigger. 8 will go into both. And if you divide both by 8, what do you get left over?
3 and 4.
Okay, 3/4?
3 or 4.
That sounds good. Well, let's say you struggle with simplifying fractions, right? Especially with the numbers. What we can use on the test is our calculator, and the good news is, if I type in the values, 24 divided by 32, what it will do is simplify it for us. Use what you're given.
What if I want the answer? So, that is the answer.
So 3 over 4. Well, it's part of the answer. It's part of the answer. It's the number. 24 over 32 will simplify to 3 over 4. So we're almost there. Now we gotta look at these values. Will the calculator do our variables for us too? Unfortunately not. I'm gonna prove it to you, but I'm still gonna probably see some people on the test try anyway. So x squared divided by x, will it give me the correct simplified solution? Uh-oh, what happens?
It don't.
It don't work with variables. So what you have to do is use your laws of exponents or some logic here. X squared divided by x. Can anybody remember?
Just x.
Okay, very good. But what was our laws of exponents? When I divide, I'm doing what with the exponents? Subtract. So what's 2 minus 1?
1.
1. And does that x, does it go on the top or the bottom?
Top.
The top, because that's where my largest number is, right? If I were to expand this out and look at it the way it's naturally written, x squared over x, what happens when you have the same number on the top and the bottom?
Cancel.
They cancel. And I see here, where's that one lone x?
At the top.
At the top. So let's look at y. Y over y cubed. Where's my largest exponent? The biggest power is on the bottom, so my y is going to stay on the bottom. Does that make sense? And what I'm going to do, I'm going to take the top y here, 1 away from the bottom, which has 3, and I'm left with what? A y squared. And again, if you didn't see that, we can write this out the way it is. Y divided by 3y's. 1y will cancel with 1y on the bottom. Leaves me with 2y's on the bottom. Y squared. So there's my simplified rational. 24x squared y over 32xy cubed simplifies to 3x over 4y squared. Are these two the same thing? Are these the same number? If I were to graph these two, would I get the same graph? Yes. One is just a simplified version of the other. So that just should be kind of a review. We kind of did this the first week, 2 weeks of school. Let's get into something we started doing before this unit here, which was factoring. First off, let me put these in factored form already. So I have 15y times y plus 1 and 45y squared times y plus 1. Now notice, what do I have the same that's on the top and the bottom is a y plus 1 factor, correct? Now here's a question I'm gonna ask. Can I take these out individually and cancel this one with this one? And this y with this y? Or must they stay grouped together?
I think you cancel it.
How do I cancel? Separately, or do I have to cancel them as a group? As a group, very good. If you see an add or subtract next to a number, you have to have it grouped together. If you don't see the parentheses there, it is bounded to that value. So when I start canceling these, I need to cancel these as a group. Good news is, do I have the same group? Y plus 1 on the top and the bottom? I do. So I could cancel y plus 1s as a group. Now I could just focus on the rest of this. What's 15 over 45 simplified to?
1/3.
Ooh, is it? Let's check with the calculator.
He's cheating. 1/3.
1/3 sounds right. Hey, calculator's not cheating. Notice there wasn't an option there that says calculator, right? 15 divided by 45 is, very nice, 1/3. So 1 over 3. And then what about the variable y?
It would be 1 y at the bottom.
It'd be 1y at the bottom. Does that look good?
Yes.
Where's the biggest y exponent?
At the bottom.
On the bottom. And I'm taking 1 away from 2, so I'm left with a 1, right? So it looks like this whole thing will just simplify to 1 over 3y. Where I can cancel these out as long as they are grouped together. Let's say it was y plus 1 over y plus 2. Are these the same?
No.
No. But can I still cancel out these y's?
No, because
No. I know I'm going to see some of you do this when I see you show your work, but no, you cannot. They are grouped, right? Order of operations.
Wait, would you have to multiply by? Wait, never mind.
No, if this was your answer, then you were just kind of stuck here with a y plus 1 and a y plus 2. They're different numbers.
What if it's minus and one is plus equal?
Ah, very good question. Let's look at that as well. So let's say this was y plus 1, y minus 1. Is all this the same? No. But wait a minute. What if I make this a negative y and a negative 1?
Don't they cancel out?
They do cancel.
Y plus 1 and negative y minus 1, are those the same numbers?
No.
They're close, right? Y, 1, 1. But what's different between the two?
The sign.
The sign.
So no.
Is it legal for me to take out a negative here? Can I take out a negative? Don't these numbers have a negative in common?
Yeah.
Yes. So they have a GCF of a negative 1. And what happens when I take away this negative? Because positive. What happens when I take away this negative? Because positive. Now, I rewritten the bottom as negative y plus 1. Now are they the same? Ah. So now can I cancel them?
So where would that negative go?
Yes. Oh, that's a good question. Where would that negative go? There's an invisible number up here on the top. What is it? A 1. There's an invisible number down here on the bottom. What is it? Negative 1. So what do you get when you have 1 divided by negative 1? That's a negative 1. Tricky. We're going to have an assignment today that actually goes over something like this. Watch out for it. Let me rewrite something again. Let me use bigger text here. X plus 7 over negative x minus 7. Can somebody tell me what this is equal to when I simplify? X plus 7 on the top, and on the bottom, a negative x minus 7.
Same thing, right? X plus 7?
Oh, what happens when you distribute that negative? So what is the solution? Ah, so on the bottom, x plus 7, right? On the top, x plus 7. Ah, 1.
So the simplified version would just be 1?
The answer would just be 1 there. So there's only a limited number of things you can do to manipulate numbers, but one thing you can do is move negatives around. If your numbers look the same, but they're not matching up as far as the sign, then you could take out a negative. Likewise, if you have something like this, you could bring inside a negative so that you get that x plus 7. Trick here is to see, you're supposed to simplify. Things are supposed to start matching up and canceling. So if you see two numbers that don't look like they're going to cancel, think, okay, what is Mr. Clark trying to do here? These should cancel somehow. In the case of this problem, they cancel if you distribute, or in another problem, you may have to take out a negative in order for them to match up on the top. So that's just a little tricky sidebar. We'll see several examples of that so that you don't get tripped up during the test or whatnot. In the case of this problem, I didn't have to worry about it, right? They match up perfectly with the number and the signs. Ooh. Like I said, if you struggle with factoring coming into this unit, hopefully we can figure it out by the time we complete this unit. Because, can I simplify these x squares like this so? Can I just say, okay, x squared on the top, x squared on the bottom, cancel out?
No, because they're not grouped, right?
Yes.
Opposite of that. They are grouped, right? Is there anything bound to this x squared?
No.
What about this piece? Is this piece separate from this?
Wait.
No, this is one of the most confusing things I see when students work these out. They think they can do this, but they cannot. This is all one group because this square here is waiting to be subtracted from this negative 2x and it's waiting to be subtracted from this 3. Likewise, this square is waiting for all this information that's attached to it. So like I said, if you see an adding or subtracting next to numbers, they are grouped together. Just like, what's going on here? Just like these are grouped together. Now notice these aren't because do you see an adding or subtracting between these two numbers? No, multiplying, right? The order of operations is multiplying the same level as division. So yes, that's why I could go ahead and cancel and cross out here because of the multiplication. But not with these, unless they happen to be the same term. So what do you think I have to do here? I already told you you cannot cancel the x squares together. I would have to factor, correct. Oh, this is acting weird, so let me restart it. That one. So let's go ahead and factor. Let's see the top. X squared minus 2x minus 3. The good news is we've already tested you on whether or not you can factor the complicated ones. So we'll probably keep it simple. Kind of like this. Notice I have no coefficient in front. So x squared minus 2x minus 3, I'm going to write my x and x. And to finish this off, I'm looking for two numbers that multiply to a negative 3 and add to a negative 2.
Negative 3 and 1.
Let's see, a 3 and 1 might work.
Negative 2.
How do I know that 3 is going to be negative?
Because the biggest number.
Because the biggest number is negative, which makes this positive. And what I noticed y'all didn't do on the test, but you should have, and you should do from here on out, is to just go back and check, redistribute, make sure you get the original polynomial. Because what if you had flipped the signs here,
Still got a little bit.
like so? You would have gotten the x squared here. You would have got a negative 3 here. So far, so good. But in the middle, I would have gotten a negative x and a positive 3, which would have given me a positive 2x. Oh, no, I'm looking for a negative 2x. And you only get that when it's like this. X plus 1, x minus 3. So please try to check your factored forms. So that takes care of the top. Now let me factor the bottom and see how things work out from there. So x, I'm looking for two numbers that multiply to a negative 6 and add to a negative 5. 6 and 1,
Yeah.
2 and 3 also works. Which one is it?
2 and 3.
Only one of these is going to give you the negative 5 in the middle.
Positive 1, negative 6. No,
The negative and negative.
Plus
Plus
one, negative six.
one.
No.
Negative 6 by
You can do some testing, put 2 and 3, see if you get a -5 out of that.
Oh, two and
Trust
three.
me, you won't, because if you do this, you do get a -5, but what happens when you multiply?
You gotta put
You get a
six.
+6. Uh-oh, 2 and 3 didn't work. Some had said 6 and 1. Let's try 6 and 1. 6 and 1. I know my 6 has to be negative, right? Which makes that positive.
Yeah.
So this gives me a -6x. This gives me a positive x, which gives me a -5x. So there we go.
I even voted for you.
So looks like I am factored on the top and the bottom. Do I see anything that matches up?
X plus 1.
Ah, can I cancel those?
Yes.
Yes, you can. As long as they are the exact same, you can cancel them out. That leaves me with x minus 3 on the top and x minus 6 on the bottom. Is there anything I could do with those? Nope. Right? They're just stuck as their own little separate terms.
Yeah.
So my simplified solution is x minus 3 on the top, x minus 6 on the bottom. Now note you also have some kind of checkpoint here, because the whole goal is to simplify. If you factor and there's nothing to simplify, then maybe you factored wrong. I want to go back and double check.
Yeah.
Notice, these two canceled. Perhaps I was on the right track when I factored these two. So yeah, you should have something that simplifies. Let me have you do this one. Go ahead and factor the top and the bottom, and then see if there's anything to simplify. All right, so maybe you noticed that the top was a perfect square. If not, that's okay. How did the top factor? X plus 3
I want to show you.
and x plus 3. How does the bottom factor? X plus 3, x minus 1. Let's check. 3x, negative x gives me a plus 2x. X squared and a negative 3x. That looks good. Now, is there anything to simplify from the top and the bottom? What's that? The x plus 3's, which means I'm left with what? X plus 3 on the top. Check your answer, and an x minus 1 on the bottom. Nothing I can do there. Please don't try to cancel these x's out. You cannot. Now let's look at one more. When you wrote your brochure down, you should have written down the steps of factoring. Step number 1 was to do what?
Bring down the X's.
Kind of, but we would call it something else. What was the first thing you should do when you look at something?
Check for perfect squares.
Not check for perfect squares, that's step 2. Step 1 was to do what before that? GCF, very good. Does any of my numbers have anything in common? So if I look at 2x squared and a negative 18x, what did I say twice?
2x.
All right, so they have an x in common. The numbers 2 and negative 18 have also a 2 in common. So thank you, 2x. So that's what I'm going to factor out. What would be left over inside? So if I'm taking 2 away from 2, well, it's gone.
Yeah, you should.
And I'm taking 1x away from x squared, it's just an x. And then what happens when I take away a negative 18x, take 2x away from that? What's the negative 18 divided by 2? Negative 9. And this x cancels with that x. Like I said, go back and check. If I were to go back and distribute, 2x times x is 2x squared. And 2x times negative 9 is a negative 18x. So the top looks good.
So you don't move the 2X?
I'm moving it out. So I'm taking 2x away from each of these numbers here. Basically, I'm dividing a 2x out.
Wait, so I'm about to record them.
What happened?
Wait.
Bro, he's gonna steal all that.
No, I'm
You're like,
good,
nah,
I'm
I don't
good.
get it.
Never mind. No, I'm good.
We trying to distribute back in?
So you divided by 2x, right? Because that's
Yeah,
what you see.
2x
Greatest common factor.
divided by 2x. So that'll cancel. That'll just leave me with x. Negative 18x divided by 2x.
Just see, it's not. It's negative.
That'll cancel. That'll leave me with negative 9.
Oh, okay.
That's what stays inside.
But they're talking.
You have another question?
No, sir.
What about on the bottom? 4x cubed minus 32x squared minus 36x.
4 can go into all of
Did you
them.
get a lobotomy?
A 4 can go to 11. What else do they all have in common?
1x.
1x, very nice.
And like, try fixing your brain.
So let's go ahead and take away 4x from each of these numbers here.
So
What's left over here?
x squared. X squared.
X squared. What's negative 32 divided by 4?
8.
8, okay, negative 8.
Negative 8.
And I'm taking 1x away from 2. 1 left over. What's negative 36 divided by 4?
Negative 9.
Negative 9.
My bad.
And I have 1x, I'm taking away an x.
Yeah.
No more x's.
Oh, what's that?
Now on the RA, some of y'all stopped here.
I go low.
But this polynomial right inside, after I factor out my 4x, is not completely factored, is it? I can still factor x squared minus 8x minus 9. And how does it factor? Two numbers that multiply to a negative 9 and add to a negative 8.
Negative 9 times 1.
Okay, 9 and 1.
I mean, not 9.
Which one of these is going to be negative?
9.
The bigger number, 9. Which makes this a positive one. Very good. So on the bottom I get 4x
That's how it sounds.
over x plus 1 times x minus 9. To go with my top here, 2x over x minus 9. Anything in the same on the top and the bottom?
The x
Yeah,
negative
x
9.
minus 9.
Okay, let's look. The x minus 9, this will cancel. Anything else? Can I cancel these x's here?
No,
You could divide by 2. Could you?
no, sir, no, wait.
You can divide by 2.
Do you have any kind of add or subtract between these two numbers here?
No.
No, so can I cancel them?
Yeah.
That's when it's okay,
Wait, what?
Wait, why could you cancel them? There's nothing
Because
else.
there's nothing else beside them.
because there's nothing else beside them.
Oh.
What you can't do is when you have
Oh, you
x,
just cancel the x's.
yes.
Yeah.
What you can't do is this, when they have a add or subtract next to it. What you can do is when you just have an x over x, and it's just multiplication between the two numbers.
Did you put it in?
But like you mentioned, what about the 2, the numbers? What's 2 over 4?
1/2.
1 over 2.
1.5.
Yeah.
And now I've pretty much canceled everything I can. What did I not close out? This x plus 1
Yeah.
here on the bottom. So there's my simplified radical. 1 over 2 times x plus 1.
Yeah, that's a
It's
lot.
the same
Woo!
part.
That is a lot.